Hello everyone, welcome back. Today we are going to be doing Cambridge International AS and A-Level Mathematics Paper 4 Mechanics. This is the May June 2022 series. This is the 4.1 version. Okay, so let's get started. They will also give you a list of formulae, the F19. The formulae that you will be given are the kinematics equation. So any other equations will not be given except the Suvash equation. Okay, and also one thing that you need to know is that the acceleration due to gravity, you have to use g, which is 10 meters per second. In physics, you use 9.81 meter per second square. But in mechanics, you use 10 meters per second. So that's something that you also have to note. Okay. We have 1 hour and 15 minutes, so let's get started. Okay, so question number 1. A car starts from rest and moves in a straight line with a constant acceleration for a distance of 200 meters. Reaching a speed of 25 meters per second, the car then travels at this speed for 400 meters before decelerating uniformly to over a period of 5 seconds. Find the time for which the car is accelerating. Okay. So from rest, we know that the car has an initial velocity, which is represented by u, of 0 meters per second. And then we know that the distance that it moves is 200 meters. And then the final velocity that it reaches is 25 meters per second. Okay, the car then travels, this is part 1, it then travels at the speed, which is u is equal to 25 meters per second for 400 meters, so another 400 meters, and then before decelerating, and then it decelerates for a period of 5 seconds, so t is equal to 5 seconds. Okay, so we know these two information now. So we want to know the constant acceleration from part 1. We want to know how much it is accelerating in part 1. Okay, so we know the v, we know the u, we know the distance. So there's one equation which links all of these together, and this is the equation given by v squared equal u squared plus 2as. Okay, so the final velocity is 25 squared. U is 0 squared plus 2. Acceleration is the unknown variable that we have to find, and the distance is 200 meters. So we solve this out. This is 400. A is equal to 25 squared, so A is equal to 1.562 meters per second. Okay, so we know that the constant acceleration for which it is traveling in the first 200 meters per second. But we want to know the time. So for time, we have to use this formula. We know that v is equal to u plus at. So a is equal to v minus u over t. I'm sorry, we have to find the time. So time is equal to v minus u over a. So t is equal to change in v over a. So we got that the initial velocity is 0, the final velocity is 25. The acceleration, we got this value, so 1.562. Now this is going to give us approximately 16 seconds. So the time will be 16 seconds approximately. Approximately, it will give us 16 seconds. Okay, so we now have to sketch the velocity time graph for the motion of the car, showing the key points. Now this is probably 2 marks as well, so we can sketch this out. Okay, I'm going to draw the graph. So this is the v velocity. Velocity is in the y-axis, the time is in the x-axis. So we write velocity time graph. Now at 0, we're going to start at initial because the car starts from rest. So it's going to start from 0, and then it's going to travel, right? It's going to, the final velocity is going to be 25. So we can draw up to 25. That is going to travel up to 25. Okay. but we don't know how long it will travel. But we did find from this, from question 1a, we found the time for which the car is accelerating. So it's accelerating from 0 to 25 for 16 seconds, right? For 16 seconds. And then we are going to be finding the time at which it is at rest, so at which it's going at a constant speed. Travel at speed, right? So for 400, we want to know the second part, right? The second part where the car is traveling at a speed of 400 meters. So for this, we can use v is equal to distance divided by time. So time is equal to distance divided by velocity. So this is, the distance is 400. Remember, 400 at the speed, which is 25. This is giving us 16 seconds. So it's going to travel for another 15 seconds at the same speed again. Okay, so it's going to be another 16 seconds. So 16 plus 16 is 32 seconds. Okay, lastly, we have to find period of 5 seconds. It's going to decelerate uniformly. So it's going to decelerate somewhere, something like this. So the graph is going to look something like this. And it's going to be 37 because it decelerates for 5 seconds. Okay? So there's something, a rough sketch of how your graph would look like. Okay. C, find the average speed of the car during its motion. Okay, so the average is basically v average. Velocity average is basically the total distance divided by the total time taken. So the total time here from the graph you can see is 37 seconds, and the total distance is the sum of all these areas. So remember, the distance is basically the area under VT graph. So under VT graph, so this area, part 1 plus part 2 plus part 3. Okay, so the total distance, let's find it. So the total distance we can find under the graph, or you can just look at from the question. So the question already states the first part 200 meters, second part 400 meters. Right, we just need to know the last part. We don't know the last part distance. So the first and second part, we know 200 in the first part, 400 in the second part, and in third part we have to find the distance. So we can find it by calculating the area of this triangle, which is 1 by 2 times 5 times 25. This is the distance 5. This is 25. Okay, so this total distance gives us 66.2.5 meters. Now the V average is going to be 662.5 divided by 37. This is the total time. Therefore, it's giving us 17.9 meters per second. And this is your average velocity. Okay. Moving on. Question number 2. Two particles P and Q of masses 0.5 and 0.3 respectively are connected by a light inextensible string. The string is taut and P is vertically above Q. A force of magnitude 10 newtons is applied to P vertically upwards. Find the acceleration of the particles and the tension in the string connecting them. Okay. So for this question, we will have to draw a small sketch. Okay? To draw this small sketch, we are going to draw this. Okay. So two particles P and Q are connected by a string, right? Connected by a string. The string is taut and P is vertically above Q. So P, this is going to be P, this is going to be Q. Okay? So this mass and this mass are connected by a string. The string is torn by, a force of 10 magnitude is applied to P vertically upward. So a force is going to apply 10 newtons vertically upward. And there, the string is torn, so there's a tension between these two objects. Okay? And here we have the weight of Q and the weight of P to consider as well. So the mass of P is given 0.5 kilogram, mass of Q given 0.3 kilogram. Okay, the force that is applied is 10 newtons. Okay, so we have to actually resolve it in separate parts. So how do we resolve it? So this part we're going to resolve it. We're going to resolve for P and we're going to resolve it for Q. So we are going to actually split it up into two parts. Okay, so we are going to resolve the force. Okay, resolve the forces about P and Q. Okay, so for P we have to know the information, which is that delta as the sigma of F is equal to ma. So what does this mean? This means that the total for F equal ma. This is Newton's second law, and it's a very powerful law. If you understand this equation, you can virtually solve any problems that you encounter or any problems that Cambridge might ask you. So the force of P, the net force of P about point P, is multiplied by the mass of P times the acceleration. Now note that the acceleration of the particles, right? So the acceleration is the same for P and acceleration is the same for Q, because acceleration is constant, right? Acceleration is constant throughout the system. The acceleration is shared throughout the whole system. Okay, so taking that into account, we know the acceleration is the same, so we don't have to write for anything from that. Now let's take a look at P, Fp. So this is P, right? The above one is P. So we have the force, which is 10 newtons up, the force, and we have the weight of P, which is acting downwards, so we have to minus it. And then we have the tension which is also acting downwards, so we have to minus it. So this is giving us MPa. Okay, so if we substitute the values, 10 minus 0.5, which is the mass. Remember, W is equal to mg. So 0.5 is the mass of P times G minus T is equal to 0.5 times A. Now this is our equation number 1. Now we have to resolve in Q using the mass of Q. Okay, so the mass of Q, we can see the tension is acting upwards and the weight of Q is acting downwards. Q is acting downwards, so this is MQA. So we can substitute it. T is equal to minus 0.3 mass of Q. W equal mg. Remember, 0.3 A. So this we can rearrange to put T in one side. So 0.3 A plus 0.373 G. So this is our second equation. Now we get two equations. We can simultaneously solve them. So we can add 2 into 1. Solving it, this is 10 minus 0.5 G minus 0.3 A plus 0.3 G equals 0.5 A. Okay, so this is going to give us 0.08 current G equals 0.8 A. If you work it out, I worked it out already, so I'm kind of fast. I'm going kind of fast here. So A is equal to 10 minus 0.8 times 10. Remember, G value is 10 divided by 0.8. Acceleration is 2.5 meters per second squared. Now you get acceleration already. So, and then we have to find, the question asks to find tension. So we can virtually replace acceleration in equation 1 or 2, but it looks like to find tension we can replace in 2. So from equation number 2, we can add this 2.5, so 0.3, 2.5, 0.3, 10. Now this gives us a tension value of 3.75 Newton. Okay, so this is our final answer, and we get 5 marks for solving that. Okay, question number 3. A crate of mass 300 kilograms is at rest on a rough horizontal ground. The coefficient of friction between the crate and the ground is 0.5. A force of magnitude x acting at an angle above the horizontal is applied to the crate where sine alpha is equal to 0.28. find the greatest value for x for which the crate remains at rest. Okay. So we have to actually draw a sketch, a little rough sketch. Now it's really helpful to draw a very simplistic diagram of sketch before you solve any problems, because it actually helps with the thinking process and everything. So let's say a mass which is 300 kilograms is resting down right on this floor. Is on rest. Okay, so the coefficient, so there's friction in the ground, so mu is equal to 0.5. Force of magnitude x is acting at an angle, right? A force of angle is acting from the center, is acting from this center. It's gonna act, right? It's gonna act at an angle alpha. Okay, this alpha, this is the force x. And remember, it does not say, however, we know that there's a weight down here. There's a weight of the box and the resistance, the Fu. Fu is basically the frictional force. You can use any annotations to annotate the frictional force. I use Fu because it's just more simple. So now let's write what is given. So the mass is 300 kilograms. Mu is equal to 0.5. Sine alpha is equal to 0.28. So we are given sine alpha is equal to 0.28. So we can also find cos alpha. Cos alpha is how much? We don't know that. But we'll need cos alpha later. So let's leave this for a while. So let's discuss about this. The greatest value of x. So if you want the greatest value of x when the crate does not move, the frictional force has to be greater than the x, right? X. But remember, frictional force is horizontal, so we have to use the horizontal component of x. So because it is in the horizontal direction, this is x cos theta is cos theta. So we have to find cos alpha. Okay, so the cos alpha is when you solve that out, you get 0.96. Okay, so this is when the greatest value of x before it starts moving. So basically, just before it starts moving, the frictional force is still greater than the horizontal force. So basically, the frictional force, which is mu r, like this. So frictional force equal x cos theta. I'm going to find x is mu r is equal to x cos alpha. Okay, so remember, this r is the normal contact force. The normal contact force is basically the force that is acting against the block. So basically its weight, right? The weight and the normal contact force are equal but opposite in direction. According to Newton's third law, an object A will exert a force on object B with an equal and opposite force, basically. So that's due to Newton's third law. So basically, R is the weight, right? So you can write R is the weight. But however, R is the resultant of the weight. So there's weight here, but there's also this, if you notice, there's also the vertical component of this force, X. So this horizontal component is X sine alpha. So this is going to be, because it's not moving, we have to minus from the weight, right? It's still, the block is still on the table. It's not moving upwards, it's not floating in the air. So the weight has to be minus from the vertical component, which is Vx sine alpha equal x cos alpha. Okay, so we can expand this. Bring the x into the same side. Okay, so we can take out the x. Sine alpha mu w. So then we can make x the subject. Mu w is equal to cos alpha plus mu sine alpha. Okay, so this is basically, now we can just substitute a value. Now I have a habit or tendency to write out everything first and then substitute the values later, because I just find that really easy. You could do it like you could substitute the values at this early stage, but this is, I feel like it gives you less error. So right, x, you just substitute the value. So we know that mu is 0.5, right? The weight the weight is, remember, weight is equal to mg. So the mass, which is 300 times 10. Now the cos alpha we got 0.96 plus mu, which is 0.5, and sine alpha, which is given in the question, 0.28. Now if you solve this, x is equal to 1363.63 ... So we can round that up to x is equal to roughly 1360 newtons. Okay, and this is how you solve for question number 3. Now question number 4, 3 coplanar forces of magnitude 20 Newton, 100 Newton F act at a point. The ratio of these forces is shown in the diagram. Given that these forces are in equilibrium, find F and alpha. Well, if they are in equilibrium, the forces in the x direction and the forces in the y direction the resultant force has to be equal to 0. Okay, has to be equal to 0. So here, this is we can draw this out. This is the Fy, this is the Fx. Here we get By, right? This is Bx. Okay, I'm using B as a variable. You can choose any number. This is A, y, and Ax. Okay. This is B. This is A. Okay. So they are in equilibrium. So the resultant force in every direction, in the direction, the resultant force in the x direction and resultant force in the y direction has to be equal to 0. And this is a very important point when they mention in equilibrium. Now, in Rx, in the horizontal solution, in the horizontal, in the x direction we have, in the x direction, in the x resultant, we have Fx, which is in this direction. Remember, we are going to use positive to the right. You get positive vector. To the up, you use positive vector. If you go left, you could use negative. If you go down, you use negative. Okay. So we're following that basis. So here we go in the horizontal. We have this Fx, which is in the right direction. Fx minus the Ax version, which because it's in the opposite side, minus the Bx, right? Bx over here. This one that's going this side. This is also going this side. So minus Bx is equal to 0. Now, Fx is basically F cos alpha, right? F cos alpha minus Ax is basically because Ax is basically 20 cos 40, right? So we can just write A, which is 20 cos 40, and Bx is basically 100 sine 20, because it is going away from the angle. If it's away from the angle, it is sine. If it's near the angle, you use cos. It's something that you just learn if you do many problems. So F cos alpha, you get 49.5229 something. And this is our equation number 1. So in the y direction, in the vertical direction, you just look at the diagram again. This one, right? And this one, there are 2 forces acting upward and 1 force acting downwards. So, right, the resultant of y is given by equal to Fy, right, which is acting upwards, Ay acting upwards minus By is acting downwards equals 0. So F sine alpha plus A sine 40 minus B cos 20 equals 0. So F sine alpha plus 20 sine 40 minus 100 cos 20 equals 0. So F sine alpha equal 100 cos 20 minus 20 sine 40. So F sine alpha is equal to 81.1135. This is equation number 2. Now we got these two solutions already, so if we can divide 2 by 1, we can actually get a ratio. Why am I dividing 2 by 1? Well, because remember, tangent theta is equal to sine alpha over cos alpha. Basically this, we want a tangent ratio. So F sine alpha equal 81.1135. This is being divided by F cos alpha, which is 49.5229. We divide these two, the F will cancel out, and this will produce a tangent ratio giving 81.1135 divided by 49.5219. Okay, put that into your calculator, use tan inverse, put this exact number, you'll get 58.6 degrees as the angle. Now if you want to get F, right, you can substitute this angle, substitute into equation F sine 58.6 equal 81.1135. This is given from this first one. So we can just write F is equal to 95.0 meters. And that is question. So you answered 2 of these already. Okay. Moving on to question number 5. Okay, so in question number 5, this is a power question. And work done, energy power question. Okay. So 2 racing cars A and B are at rest alongside each other at point O at straight horizontal paths. Okay, let's write down the given information first. This is what you do in mechanics. So the mass of car A is 1,200 kilograms. The engine, right? The engine produces a constant driving force. The constant driving force of A produces 4,500 newtons, and when A arrives at P, its point P, its speed is 25. Okay, so velocity at point P is 25 meters per second. Okay, when A arrives, okay, the distance OP is D meters. The work done against the distance for experienced by A and OP is 0. Okay, so the work done by the resistance is basically 75,000 joules. Okay, this is done by the resistance, the work done against resistance. So let's draw a little diagram as always. We draw a little crate here. We draw this here. Now the forward direction is the driving force by the engine, which is Fa. Okay, and then there's a frictional force. Remember, there's a frictional force at this point original. This at its resting position, and when it is at P, right, it moves a distance P. There's velocity is 25 meters per second. So initial is 0 meters per second because it is at rest. Okay, so we have to use the work done energy equation because work energy equation. So basically that the work done energy, basically the change in kinetic energy is basically equal to the sum of all the work done. This is a very important concept you have to remember. The change in kinetic energy is equal to the work done, the net of the work done. So remember, kinetic energy has a formula. 1/2 mv squared, but change in kinetic energy is v squared minus u squared. So this is going to be 1/2 m, the mass of A, v final minus v initial squared, equal the W work done by the engine, which is A, work done by the engine, which is FA, minus the work done by the resistance. Okay, so because we are going to cancel this one, because remember initial is there at rest 0 meters per second, so we can rewrite this as Vf the whole square equal, now work done by the engine is basically the F, force done by the driving force times the distance that it moves, because work done is basically force times the distance in that direction, minus the work done of the resistance. We don't write this as F resistance times S, because we are not given the resistance force. Instead, we are given its whole number, which is this one. We are given this one, so we don't actually do anything to that. Okay, so we rearrange the D because they want to show that D is equal to 100. So we can rearrange this equation. Okay, now we can substitute the values. So the mass of A is 1,200. Final velocity 25 squared plus 75,000 divided by 4,500. Now this will give you an answer of 100. So this is proved that D is indeed 100 meters between O and P. Okay, and you get 3 marks for that. Okay, this is the continuation. Car B starts off at the same instant as car A. The two cars arrive at P simultaneously and with the same speed. The engine of B contributed to the driving force of 3,200 newtons. P simultaneously with the same speed. The engine of B produced a driving force of 3,200 newtons. The car experienced a constant resistance to motion of 1,200 newtons. So we are given now the result, the frictional force, right? So we have to find the mass of B. Well, it has the same speed. So it is initially 0 meters per second, the same as A. Final speed also 25 meters per second. Okay. Now we are given the force. The force resistant, right? The force of resistance, which is 1,200 newton. Resistant force. The force opposing the motion, right? And it has the same, produces the driving force of, okay, so the different thing is that they produce driving force of 3,200 newton. Okay, so we draw the sketch thing again, the box, right? The forward, obviously the forward has to be greater than the resistance, or not, it will not move forward, right? So we use a work energy equation again. So this change in kinetic energy is equal to the summation of work done, the net work done. So 1/2 mvf square minus vi the whole square equal wb, which is the driving force, work done by a driving force, minus the work done by the resultant, work done by the resistance force. So we can cancel this out because it starts from rest, times mv times vf the whole square, and this equal to, remember, work done by the force. My work done by the force is basically fb times distance, and then we're given the force, resistance force, which is Fr times d. So we can write this as, we can take out d from the equation, right? dFb minus Fr. So we can write it like that. So we can erase this one, and we're going to use this one instead. Okay. So we can rearrange, find b, which is 2d fb minus fr over vf the whole square. Now substitute all the values. 2 times d is still 100, since we find it from there, times 3,200. Substitute the values, it's easy as that. So yeah, so 640 kilograms. This is your final answer. Okay. We still have two more questions. Okay. Find the steady speed which B can maintain when its energy is working at the same rate as it is at P. The steady speed which B can maintain when its energy is working at the same rate at P. So the walking at the same rate, this is meaning power. Find the speed when the power is the same as P. Okay. Remember, power is equal to force times the velocity. So the power at P is equal to the force of the driving force times the velocity at P. So this is 3,200, which is produced by car B, times velocity, which is 25. So this produces a driving force power of 80 kilowatts, or 80,000 watts, okay? Or joules per second. So we can write the summation of FB equal mb over a, because according to Newton's second law, F equal ma, the forces have to be equal because a is equal to 0, right? The acceleration is 0, right, at that point, because it is a constant speed. And therefore, there will be no resultant force, so the FB has to be equal to 0. So FB minus FR equal to 0. And this gives 80,000 divided by V, right? So because power is equal to F times velocity, we want F, so F is equal to 80,000. We're given the power over, sorry, of the wrong equation. So power is equal to force times velocity, right? We want force, so force will equal to power over velocity. So we're basically putting this here. The power produced by the engine is 80,000 watts divided by the velocity, which is the variable we're going to find, minus the resistance, which is given from the question. So if we solve this equation, it kind of looks like this. So the steady speed will be 66.7 meters per second. Okay. And that's your free 3 marks as well. Question 6. A particle starts from point O and moves in a straight line. Velocity of particle at time. Okay, you're given by this formula. K is constant. Verify the particle's return to O when T is equal to 2. Okay, how will we verify? So the displacement has to be 0 meters because it returns to its starting point, O. It starts from O, right? Comes back to O. So the displacement between is 0 meters. Okay, we have to prove this basically. So we are given velocity, right? Velocity. So velocity is basically equal to ds by dt. So ds by dt is equal to this k, right? K is equal to 3t squared minus 2t cubed. So we want ds, right? We want s. So we're going to k 3t squared minus 2t cubed dt. Now we can integrate both sides to get displacement. The displacement is basically the integral of velocity, okay? And the limit here will be from 0 to 2 because, right, it's moving from 0, and then when time is equal to 2, right? Time equals 0 to time equal 2. You're integrating it with respect to time. Okay, so you can integrate this. So integrate it like how you would normally would. So you can take out the k here. So 3t cubed over 3. Cancel this out. Minus 2t 4 by 4. You can cancel this out. 2 0 to dt. So s is equal to kt cubed minus 1 by 2 t4. Now substitute the values like you would normally do. 2 cubed minus 2 4 over 2, okay, and then minus 0 because 0 times 0 cube is 0, and 0 times 1 by 2 to the power 4 is also 0. So the particle will also equal to 0, and therefore we can see that the particle has displacement of 0 at time t2. So we prove this. You get 4 marks. Okay, B. It is given that the acceleration of a particle is minus 13.5 meters per second for the positive value of t at which v is equal to 0. Find k and hence find the total distance in the first 2 seconds of motion. Now this is a 6 marker. We do have to think pretty much. Okay, so we can draw a diagram. This ball is going to travel right from time t equal 2 seconds. Right, we don't know the time of how it will be. Find the total distance in the first 2 seconds of motion. We don't know what is the distance. So it will go v is equal to 0, okay? It will go back, right? So the ball goes and it will go back because we just proved that at time equals 0, the displacement is 0, so it will remain. It will go from here to here and then go back. So there will be 2 distances that we have to calculate. So let's write down the given information. We are given the acceleration. We are given. Okay. We're not given the time at which it turns around, time at which the ball turns around. So the ball turns around when v is equal to 0, because that's something that you have to know. Because when the ball turns around, the speed, the velocity is at that moment, at that interval is 0. So you have to know that v is equal to 0 when it turns around. So 0 is equal to k3t cubed minus 2t cubed. So 0 is equal to 3t squared minus 2t cubed, because k, we divide this whole equation by k. So 0 equal to t squared. You can take out t squared. So 3t squared is equal to 0. T is equal to 0. Or 3 minus 2t is equal to 0. So this will give us 2t is equal to 3. T is equal to 3 by 2, which is 1.5 seconds. So it will turn around at 1.5 seconds. At 1.5 seconds. And you have to remember, displacement is basically the integral of velocity with respect to time. So we will have to find the displacement, which is the integral from 0 to 1.5 to the point at which it turns around. 3t squared minus 2t cubed. Right, so from when it starts to when it turns around, to turning around. Okay, and then we have to multiply this whole integral by 2 because of it's asking for total distance. Okay, so we have to then find the velocity. We don't know the velocity currently. So v is given by k3t squared minus 2t cubed, right? The acceleration is basically dv by dt. So we can we have to differentiate this one. So acceleration is equal to k6t minus 6t squared, right? So when t is equal to 1.5, acceleration is equal to minus 13.5 meters per second. We can find the value of k. The value of k is, we can just substitute it over here. K. So we don't know what k is. We can substitute 6, 1.5, and 6, 1.5, the whole square equal minus 13.5. Right, so k is equal to 3. Okay, so k is equal to, now that we know the k value, we can just integrate it now. As is equal from this one, from this above, we can integrate it. So 3 t to the power cube minus 1 by 2 t to the power 4. This is the integrate from 1 to 0. This 3 is the k, okay? This 3 is the k, don't get confused. So you can just integrate it, 1.5, substitute the values that are given, 1.5 to the power 4, 0. Okay, so the distance is equal to 2.53125. Now, because it is asking what total it is, we times it by 2, so this gives us 5.06 meters. And this is your final answer. Now, this question, you do have to think about when the ball turns, the time it takes to turn. Okay. So you get 6 marks for that question. Okay, last question is a momentum question. 2 particles A and B masses this one, blah blah blah, moving down. So okay, it is an inclined smooth plane, inclined 30 degrees horizontal. A is higher up the plane than B. When the particles collide, the speed of A and B are 3 into the speed of A is produced. Okay, so momentum, using the principle of momentum. Basically, momentum before, the summation of moment before has to be equal to summation of momentum after the collision. After the collision and before collision has to be equal. Now that's the principle of momentum. Now if we draw a slope, we can draw a layer diagram. This is theta, this is A. Remember, it says in the question, A is higher up in the plane than B. So the mass of A, we are given 0.4 kilogram. Mass of B, we are given 0.2 kilogram. Now before the V1, the speed of A is 3 meters per second. And B, the V2, is given as 2 meters per second. Now after, for A, the speed of V3 is 2.5 meters per second, and V4, we only find the V4, which is the speed of B immediately after the collision. So the speed of V4 is basically the change of momentum before. So before this one, this is 0.2 times V4 equals, okay, sorry, I skipped too much steps. So basically what we have to do is MA V1 plus MB V2. This before has to be equal to MA V3 plus MB V4. We just don't know the V4. But we know every single value, so we can just substitute it. Okay, so 0.4 times 3 plus 0.2 times 2, 0.4 times 2.5 plus 0.2 V4. So when you solve that out, 0.2 V4 is equal to 0.6. So 4V is equal to 3 meters per second. This is the speed of B immediately after the collision. So the last one is a 7-marker question. You have to think this a lot. Okay. After the collision, when B has moved 6.1 down the plane of the y, it hits the barrier and returns back up to the line of same greater slope. B hits the barrier 0.4 seconds after the collision, and when it hits the barrier, its speed is reduced by 90%. The 2 particles collide again 0.4 after their previous collision. They can coalescence. Now, coalescence, what this means is that they will move together after second collision. So basically, there's 2 collisions that's taking place. When A and B collide together, the B will hit a barrier, it will return back, will go up the slope, and the B will then hit A again, and they'll move together upwards on impact. So basically, we have to draw a diagram for this as well. It's always easier if you draw a diagram. This is 30 degrees we're given. So we are given the slope, right? 1.6 down the slope. It has moved 1.6 meter down the slope. We know the weight, right? The weight of this one. We know this one as well. we know that the v4 after the collision is 3 meters per second. This is we found it here. Okay, so we must also use the data from above. So we know that v4 is 3 meters per second. We know that this distance is 1.6 meters. We don't know the acceleration yet. Okay, so according to this, we have to use v squared equal to u squared plus 2es. So what is it going to show? The speed of immediately after it is the barrier of it. Hence, find the speed of the combined particle. Okay, so there's 2 questions they're asking. So we have to find acceleration first. Okay. Okay, so v squared equal to u squared plus 2as. So acceleration is basically equal to g sine theta, because this is g acting out one with g, and then the sine theta, this one, is acting downwards. So the acceleration is going to be 10 times sine 30. The acceleration is equal to 5 meters per second. So putting this into the v squared minus u squared, v squared equal to 3 the whole square plus 2 plus 5 times 1.6. So this is given 2 accelerations. We just found the acceleration from here. So v1 is equal to 25 v squared, so v is equal to 5 meters per second. So this 5 meters per second is actually the speed of b, right? However, after the collision, right? So after collision. However, its speed is reduced by 90%, right? The speed is reduced by 90%, so speed is reduced by 90%. This means that your total value would only be 10%, right? So 100 minus 90 is equal to 10. So the speed of b after hitting the barrier is equal to 5 times 0.1, which is basically 10%. This gives us 0.5 meters per second. So the v5 is 0.5 meters per second after it hits this barrier. There's a barrier here. After it hits the barrier, its speed is reduced by 90%, right? The vb is reduced by 0.1 vb because it's reduced by 90%. Okay. Now it asks to find the speed of the combined particle. So we have to draw that particle again. So we have to draw a diagram. For A, we can see that the particle is going downwards. The acceleration is still the same, 5 meters per second. It's the same as B, right? So V3 is equal to 2.5 meters per second. V3, where do we get V3? V3 is given in the question above. Remember to always recheck the question because the questions are often connected. Now the time is 0.44 seconds. We want to find the V6 of A. Okay, so A is equal to V minus U over T. So V is equal to U plus AT. U initial velocity is 2.5, right? Plus acceleration is 5, time is 0.44. 0.44 is given in the question. The two particles collide again at 0.44 after the previous collision, okay? So the velocity of A will be 4.7 meters per second. This is velocity of A just before collision. So we haven't actually collided yet before collision. Okay. So for B, we will draw a diagram again, because in this case, the ball is actually going back up after it hit the barrier. So it rebounds from the barrier, okay? So we know V5 is equal to 0.5 meters per second. This is the speed after the collision with the barrier, which we found from here. Okay, V5 is 0.5. The acceleration is minus 5 meters per second. Why? Because it's going in the opposite direction. First time we calculated the b is downwards is 5, so upwards has to be minus 5. Okay, that's a very important notation. The time is going to be 0.44 minus 0.4, because 0.44 is the time after the hit, and 0.4 is the 0.44 is when the two particles collide, and 0.4 seconds is when B hits the barrier. So we want to find the difference between the time, which is 0.04. So according to V equal U plus or minus AT, this will equal 0.5 plus minus 5 is 0.04. So VB rebounding 0.3 meters per second. This is also before collision. So we can draw another graph here where A will move with speed velocity A and B will move at velocity B. This is before and after. They will both stick together, they will coalescence, and they will move together upwards, V. So basically MAVA plus MBVB equal M total times the V combined. So 0.4 times 4.7, we already get it from here. Plus 0.2, which is the mass of B, times 0.3. This is equal to combined mass 0.6 times the V. So we want to know this V combined. So V combined is actually 3.03. And this is how I get this. Okay, the last question is kind of difficult. You do have to learn, think about it a lot, how to calculate it, about the barrier, about the 90% reduction in speed, right? Right, and you also have to draw diagrams. If you do not draw diagrams, you would literally not be able to solve this because, yeah, you need visualization. So we draw 3 diagrams in total to find 2 answers. This is the first answer to give. This is the second answer that they want. And this is all for 7 marks, okay? Okay, and also remember, notice to find minus acceleration minus 5 because it's going upwards, right? B is going upwards again, so it's going to be minus 5 because we took A going downwards acceleration as 5. So yeah, so I know you guys can do it. Mechanics is actually not that hard after you experience or solve many problems like this. Okay, so we have reached the end of the video. If you have any questions, please leave them in the comments below. Anyways, thank you for watching as always.